There we have our quadratic expression in trinomial form, and we are required to complete the square. In completing the square, this expression should be written in this form, and we can immediately see what will happen, or the consequence of transforming this to this form. We notice that the x that we have here has a coefficient of 1, and outside here we have a constant a. Therefore, if we have 3x squared here, it means that this 3 will have to some way disappear, but not completely, but be outside of the bracket, while x is inside of the pair of brackets. In the first step, we will remove the 3 that is accompanying x squared. That we will do by factorization. In our attempt to do that, the negative 12x is going to be affected. So we take the common factor of 3 in order that the x will be there by itself. However, by so doing, we will also affect the negative 12x. 3 is taken as a common factor, as we can see, and each term is divided by 3. We take 3 out. Of course, we're going to say 3 into 3x squared. The 3 will cancel the 3, and we will have x squared. And we are showing it right here. Then we have 3 into 12x. 12x divided by 3, the result will be 4. There we go. 3x squared minus 4x plus 8. 3 into 3x squared is x squared. And 3 into negative 12x, we will have 3 into negative 12 is 4, and the x returns. So we'll have x squared minus 4x plus 8. In the brackets, complete the square by taking half of the middle coefficient and squaring the result. Half of the middle coefficient and squaring the result. Now, what we have here is a binomial, but we need a trinomial, and that trinomial is required to represent a perfect square. For us to have that trinomial and for it to represent a perfect square, we need to take half of this middle coefficient, and we need to square it. So half of negative 4 is negative 2, which when we square, we get 4. 2 squared, or negative 2 squared, will be 4. Therefore, inside here, accompanying these two terms, we'll have a square term, which is positive 4. Notice that everything is the same, with the exception that this 4 is added. And this 4 is what is required to complete the square. We take half of the middle coefficient and square it. Therefore, we have a complete square inside here, a perfect square, and this square is completed. However, we introduce this 4 that was not there before. It is therefore unaccounted for. Because it is unaccounted for, we have to give an account for it. Or we will have to do something that will have a cancelling effect on it. So either of those two. That 4 was not there before, therefore we intend to subtract 4. So what we should do in the long run is subtract 4 in order to compensate for this 4 that we just added. However, it is inside of the brackets, and everything inside of this bracket is multiplied by 3. Therefore, we have not just introduced 4, but because it is multiplied by 3, we have introduced 12. Therefore, we need to subtract 12. And there we are, subtracting 12 in order to compensate for this 4 that was added, which was eventually multiplied by 3. Now we have a perfect square. How do we arrive at that perfect square? The first term in a perfect square is the square of something. And this x squared is the square of x. Also, the final term, which is the third term in the perfect square, is a square term. It is the square of something. We know that 4 is the square of positive 2, and we know that it is also the square of negative 2. However, the middle term is negative. So we are sure that the other term is negative 2. In writing the expression as a perfect square, consider that the first term in the brackets is the square of x. That's why x is there. And the third term is also a square term, which we know that 4 is the square of 2 and the square of negative 2. The middle term is negative, which is this one. This tells us that we need to consider the negative square root in order that the negative middle term may be generated. Notice that from the beginning, the middle term has been negative. It has been nothing but negative. And in order that when we complete the square, and if we try to reconcile the original expression, then in order for us to get this expression with a negative middle term, then we will have to have a negative term here. And this is no cheating by any means, because the square root of 4 is not only positive 2, it is also a negative 2. So we are sure that negative 2 is the one that is required. No doubt, 8 minus 12 is negative 4, and the expression is written in the required form. A is 3x minus 2. B is negative 2 plus h. H is negative 4. And we have the expression written in this form, which is really the statement of the problem when we are required to complete the square in an examination. For access to hundreds of free videos, please subscribe to our YouTube channel, Richard James Mathematics Resources. For unlimited access to thousands of exclusive full-length videos, please subscribe to our Vimeo channel, Richard James Mathematics Resources.